How does Arctic sea smoke form? Have you ever seen a mysterious fog rising from the ocean in the Arctic? That phenomenon is known as Arctic sea smoke. So, how does this captivating sight come to be? Let's break it down. Arctic sea smoke forms when very cold air moves over warmer patches of open water in the Arctic sea ice. This happens under specific conditions where temperature differences and moisture play a key role. The process starts with evaporation. The warmer water releases water vapor into the air above it. As this vapor rises, it meets the much colder air above. Cold air cannot hold as much moisture as warm air. So, when the warm, moist air rises and cools quickly, it drops below its dew point. This is the temperature where air becomes saturated and water vapor condenses into tiny droplets. This condensation creates the fog that looks like smoke rising from the water. Typically, this fog is shallow, sitting in a thin layer just above the water. However, it can sometimes form swirling columns that reach heights of 20 to 30 meters or more. The colder the air is compared to the water, the more pronounced and lasting the sea smoke will be. If the wind is strong, it can blow the fog away before it fully develops. You are most likely to see Arctic sea smoke when air temperatures are well below freezing, often below 0 degrees Celsius. Meanwhile, the water remains unfrozen and relatively warmer. This situation often occurs when sea ice breaks up, exposing patches of open water to the frigid Arctic air. The temperature difference between the cold air and the warmer water is essential for creating sea smoke. This fog is a common sight in polar environments, especially in the Arctic and Antarctic regions. It can affect visibility near coastal areas and fjords, sometimes leading to quick changes in weather that impact transportation and navigation. So, Arctic sea smoke forms through the interaction of cold air moving over warmer open water. This leads to rapid cooling and condensation of water vapor into fog. This natural occurrence highlights the unique climate and weather dynamics of polar regions, where the contrasts between sea ice and open water create stunning atmospheric effects.